Hello everyone. I am currently pursuing my master's in advanced data analytics at University of North Texas. Today I am here to present my final project of course ADTA 5560 and recurrent recurrent neural networks of sequence data. And is here coming to the part one. A project here we're supposed to provide a data set in the public domain which is available for free in a Kaggle. And without any restrictions, the data set may contain either the numeric values and the images and videos. And for the submission requirements, we're supposed to write a report on it. For the first part, I have chosen the data set named as airlines. This is my report. Here I have taken the data set named as airlines data set. It has all the details of the flight, like performance of the flight, and that flight was cancelled or delayed and would be, and if you could have predicted it, if you had more information. This is the information that the data set has. Compare the arrival and departure timings for every numerical flight inside the United States, and has between the and this data set is between October 1987 to April 2008. This is a large data set which are around 120 million records, which has a compressed size of 1.6 gigabytes and an uncompressed size of 12 gigabytes. And this data was received from RITA, where it was absolutely detailed. You may have get the data from the zip file CSV files provided below. The variables were removed from the files to make them more close compared than original and packed in annual positions. And the explanation details of the dataset we have mentioned that clearly. Just look into the dataset. Here we mention clearly like years, month, day of week, deep time, RR time, CRS RR time, and etc. These are the large dataset which I taken in my final project. Coming to the report. This is the like my dataset details, and also I given the Kaggle dataset link which I taken from the Kaggle. And already I said right, the this time period of like span of October, this dataset is October 1987 to April 2008, and it has a data points of nearly like 120 millions. Data number is a numerical presenting number of data, since the data of original airlines data is also a numeric. And also there has the BTS, it means like Bureau of Transport and Statistics, which of the United States Department of Transportations, and DOT monitoring of on-time performance of domestic flights. It show the how the accurate and significant airlines carriers. The summary of the data on the number of on-time and delayed, and it shows that on-time, delayed, cancelled, and diverted flights may be found it on dot months, years in air travel consumer report. This which is issued around 30 days after the end of the month. And as well in the summary table on this page, this in the June 2023, the BDS, it means Bureau of Transportation Statistics, began the collecting the information of all the regions of aircrafts delayed from the United States. The when the air travel consumers report is produced, and the summary statistics and the raw data may accessible to the public, and it was displayed all the results of contributing to the delay. And this is a part one. And coming to the part two, and the coming to the part two, like here we explain about the simple RNN with the sine wave data. Here we can see build train of available simple recurrent neural networks, and that has a two layers and with a simple RNN and a fully concentrated with layer in Keras. The Keras is the best tool we can use here. Coming to the simple, and I have clearly explained here simple recurrent neural networks. First, we can look into the what it means. The RNN, it means like recurrent neural networks or a simple recurrent neural network has a single hidden vector H, and also one layer neural networks is referred to the vector H. It also only present only one hidden state vector. The feedback is contained the single layer network. It also known as vanilla neural network or ELMA RNN. And also I clearly explained here of the architecture of the RNN. And also I clearly mentioned the image of the recurrent neural network. We can see here. Coming to the architecture, its architecture is divided into two component parts. It has feed forward neural networks and simple RNN. And it has a and here two examples for a feed forward network and a simple RNN. uh, Made up of, and this feed forward network is made up of a that the layer is entirely coupled. Next, we evaluate train and access of neural network. Since there are various vendors and we will be charting and displaying data, if you want this core library, we need to import the specific mode into the Keras. The Keras here we can in this project Keras is the best tool to use the sine wave. We need to use a simple RNN layer called a dance. Only the full linked layer called as dance. This will be used to build a second network. This is a diagram of a simple neural network, and also like this is the data is a screenshot of where I we can use the in Python. We import all the libraries here, and Also, we can create a sine wave or a simple RNN. And I have clearly given the image of RNN. In the Jupyter notebook, we create a best sine wave. Here, imported all the libraries. We have written all the codes here. Now coming to the time series, the time series generator will be built next in order to fit the batteries into the model. We'll either design or manufacture a sine wave in Keras. The Keras is the best development, assignment, and training tools. The time series generated will be created next to fit the batteries into the model. We will either design or manufacture sine waves. Keras is the first tool for building, analyze, and training mode. You can see the screenshot where I can import all the libraries in this using the Jupyter notebook. And we need to know how to get the sine wave from how to create a sine wave from the Jupyter notebook. First, we all use the numpy space functions in the Jupyter notebook. There will be a 768 values or data points will be created. We ask the function to provide a 768 into the data points between 0 and 8. We have 786 x values ranging from the 0 to 50. The trigonometric function will be used from the calculate the values. It is an array and y is also an array. The graph is built using the values between the -1 and 1 to fill the data frames which all the information. These data frames will be have x and y. The index is x, which is real data is y in here. And also like we need to split the data and we need to come into the next step. We need to split data. Here we need to train the data and we need to test the data. Here we need to check whether the data set is filtered or not by using the Keras provide the fit approach. We can see here like split data and we can train. I also train data and I also test the data. You can see here. For this sequence, we will evaluate the time series input sequence to the time series generated and length is 3. Using this previous data point, we will forecast in the next one. It is necessary to provide the batch size. When we train or best the sample, we must fit into the model. A batch is a grouping of sample. It has the 50 various data points. Will we utilize the forecast of next one? In this project, we only I only examine one value of the batch size one. To create the instance, we must consider we must consider the following variables must be considered the batch size. After that, coming to the next one, we need to build the data and again we need to train the data. For the build the data and the train data, we must first build the recurrent model, the characteristics must be specified. The data frames has only attributes. We just have a one designation attribute. In addition, we sequentially API will use a keras to access a number of APIs. Here we name it model and constructed a model in keras because it is now empty. A layer must be added. A feed forward network is the second subnetwork on our single layer. To build a basic RNN, we need 100 neurons in this project. We can readily use the input sequences 50 history points when the layer has been formed. And coming to the next one, create a time series in a generate instance. We can see here everything. We need to train the data and we need to fit the data. Coming to the next one, evaluate model on the test data. Here we need to test the data. Here there is just a one sample variable to take. You only have one sample. There are 50 data points in this sample. Where the values of one character has flows that has a 3 dimensions to forecast the values. We first need to define an empty list here. The input sequence first batch must then be obtained. The last 50 points should be concluded the first batch and there is just one sample for each batch. 768 data points totaling 250 characters along make us test data. We'll use the each and there's previous 50 data points to current the batch. Here we can see the visualized mode of after training the graph. And at last is the end we can get a sine wave. Is the first we can see here. Firstly, we can discuss about we can take a time series data set in part one. All the details like I given here, which I taken from the Kaggle and the period of the time span of the data set and the how it is like how many data points it has. And in the second one, in the part two, I simply explain about the simple RNA with the sine wave data and also I given the images of the simple RNA and with the screenshots and here I split the data and also I train and test the data here. This is all the part. Thank you.